Hey, welcome to your new unit. It's all about powers and exponents. So 3.1, Introduction to Powers, and wow, that's a bit of a dog's breakfast. Exponents. Remember, we like to date our notes, and remember to write down your name, just in case you lose a page. Mine is Tara! Let's focus on this. This whole thing is what we would consider to be a power. This little number right up here, and I'm going to just highlight it in yellow. This little guy here is called your exponent. This guy that I'm going to color in pink, this guy right here is your base. So 2 to the power of 3 would be written 2 times 2 times 2. Now the reason why we are writing 2's is because that's what the base is. The base is the thing that's repeated. But it is repeated 1, 2, 3 times, which is the same thing as our exponent. So the base is the thing that gets repeated, and the number of times is that exponent. We like to get a little tricky here, though, because we can have negative, well, you'll deal with negative exponents, but negative base. So let's talk about a few different instances. If I have 3 to the power of 4, how is that different from negative 3 to the power of 4 or negative 3 to the power of 4? So let's just rewrite this as it is. So we're saying that the base is repeated the number of times the exponent says. So that means that it's 3 times 3 times 3 times 3. Now every calculator is a little bit different with the way that it writes its exponents. This one right here, though, it has x to the power of y. So I would say 3 to the power of 4. Not 44. That would be 81. negative 3 to the power of 4, this becomes our base. Now, our exponents are fickle friends. They only stick to what is exactly right beside it. Now, for this 4, it sticks exactly right right behind that 3. So the base of 3 is the thing that's being repeated 4 times. With this one, we have brackets to hold in that negative 3. So the thing that's being repeated is the negative 3. So you have negative 3 times negative 3 times negative 3 times negative 3. Now, if you are at school, look up quick to the board. Do it. And chances are I'm going to say positive and negative integers. It's going to say that on the board. What do two negatives make? A negative times a negative is a positive. Okay, so if we have this negative 3 times this negative 3, it's going to produce a positive 3. Oh, sorry. Negative 3 times negative 3 is going to be positive 9. And I'll just do that in the next step. So negative 3 times negative 3 is going to be positive 9. Negative 3 times negative 3 is also going to be positive 9. 9 times 9 is positive 81. So look at that. We did have a negative as the base. But since we're repeating it 4 times, there's an even number of negatives. So that means that the answer is going to be positive. What about this one, though? This little Lone Ranger here. The base is not negative 3 because the thing that the 4 is directly attached to is not -3, but just 3. So the negative hangs out at front, and the thing that gets repeated is the base, which is 3. And we have to multiply it together 4 times. So I know that my number is negative, because I only see one negative here, whereas here I see 4 negatives. 3 times 3 times 3 times 3 is going to be 81. So we have a very common or very similar looking bases. We have 3, we have -3, and then we have negative out in front of a base of 3. So these three things look very similar, but they produce different answers. I don't want you to see this in brackets and you say, oh, if something's in brackets, it's going to be a negative answer. Or sorry, if something's in brackets, it's going to be a positive answer. Look at this. -2 to the power of 3. -2 to the power of 3. The thing that is being repeated all that time is the -2. So my base is -2 times -2 times -2. Now this one right here, -2 times -2 is going to be +4. But then I still have to multiply by -2. Now remember, the operation that happens between those two things is multiplication, not subtraction. 4 times -2 is -8. So you have something in the brackets, you have a negative in the brackets, doesn't always produce a positive number. It depends on what that exponent is. If you have a negative base and an odd exponent, you're going to get an odd answer. If you have a negative base and you have an even exponent, you're going to get a positive answer. Let's do this one example. Write 16 as a power, and hint, there are 2 possible answers. Well, the first one that pops into my head is I'm saying, 4 times 4. So 4 times 4 is 16. But we need to write it as a power. So we're going to erase this 16. 4 times 4 is the same thing as 4 to the power of 2. Here's another thing. So this is method 1. What happens if I only deal with 2's? 2 times 2 is 4, times 2 is 8, times 2 is 16. Woot, woot, woot. So we have another potential for a power here. But I don't want the answer here. I want it to be expressed as a power. So my base here is 2. And my exponent is 1, 2, 3, 4. I'm going to be a little bit more tricky. I'm going to say that there are 4 possible answers. Look at this. -4 times -4 is also 16. So how do I express that as a power? -4 to the power of 2. Same thing here. We can have -2 times -2 times -2 times -2. That also equals 16. But if we want to write it as a power, we can say -2 to the power of 4. So if we were to summarize what we learned today, we would say powers have bases and exponents. Bases are the numbers that repeat, and exponents tell you how many times the bases are multiplied by each other. So in Math IXL,